Hi, everyone, and welcome to 15 Minutes in the Cloud. Kubernetes is evolving. Are you? Brought to you by the SNIA Cloud Storage Technologies Initiative. Today's conversation is going to be with Michael St. John, Senior Principal Marketing Manager at Red Hat Hybrid Platforms, and hopefully Alex McDonald, an independent consultant and the chair of the SNIA Cloud Storage Technologies Initiative. Alex is having a little bit of technical difficulties right now, and we hope he will be able to join us as soon as they are resolved. Hey, Michael, how are you?
I'm doing great today, Diane.
Great. So just before we get started, this is just a quick legal notice from SNIA in terms of the copyright rights to this presentation material. So, there are no warranties express or implied. So please read this if you want to reference any of this material and use at your own risk. So today's Kubernetes discussion is going to revolve around some key topics: persistence, business continuity, deployment, performance and scalability, and just some overall trends. So while we're waiting for Alex to join, Michael, maybe we'll just kind of start talking about persistence a little bit, from ephemeral to persistent. What's
Yeah.
been putting persistence in the mix done to applications?
Yeah, well, of course, containers start becoming more popular among developers and application architects. People wanted to deliver stateful applications, and thus there had to be a way to retain that persistence. And they did so by adding a persistent storage component that held the state of the application. And at first this was done statically. Typically, you would just have like an NFS mount, and it had to be manually added and then manually removed from a project. So as you deleted a project, you'd have to go in, you'd have to clean that up. Typically, it would go back to an IT administrator to do things like that. But over time, we added storage classes, and that kind of delivered more of a dynamic and an automated way of delivering that persistent storage to the applications. And then, since then, we've seen the proliferation of more and more workloads. So today, we see things like databases and data cache, warehouses and analytics, web services. A lot of AI ML workloads are coming into Kubernetes platforms, and uh, much more as some of these popular workloads come into a Kubernetes platform.
Okay, great. So what about what's happening on the business continuity side in terms of backup, recovery, DR? What's going on there?
Yeah. So as some of these workloads are being adopted in Kubernetes, as you can imagine, a lot of these applications are mission critical. They have a requirement for business continuity, right? So now, depending on the criticality of the workload, organizations might need to drive down their recovery point or their recovery time objectives as close to zero as possible. And for very sensitive data, they may also need to have a strategy that protects against disasters, and that could be disasters from within a data center, out to a campus or even a city, or even developing a strategy for regional disaster recovery, right?
Hmm.
um, so as such, business continuity for applications in Kubernetes is a growing major concern for folks, and today's solutions range from namespace backup and recovery for specific projects, or sometimes specifically for different infrastructure services within the cluster. And those can be developed and deployed by individual developers who are working on a project, for example. But then to more of the cluster-wide data protection that has complete cataloging, search, scheduling capabilities, and things like that. But then beyond that, having the ability to have replicated or stretch clusters with synchronous data can greatly reduce the RPO and RTO objectives, while also delivering asynchronous options for those regional DER capabilities. That helps to complete that business continuity strategy over time.
Hmm.
I think the key is really to deliver all of these capabilities as seamlessly and as automated as possible in Kubernetes.
Sure. And it seems like in terms of talking about business continuity and DR kind of gets into the deployment
Mm,
concerns and scenarios. I mean, Kubernetes could be delivered as a service in the cloud, on premises, the data center, at the edge.
yeah.
How is each use case different?
Sure. Yeah. Yeah. I kind of see one of the biggest advantages of a Kubernetes-based platform is that it delivers that portability with a consistent experience, regardless of the underlying platform. So, whether it's on-prem or in a public or private cloud, it makes it possible to deliver this cloud-like experience for applications, whether they're running public or private cloud, but also across on-prem deployments in a core data center or even at remote locations and at the edge. Now, there's certain things that need to be considered. For example, data sovereignty. Some data must be kept internal, maybe due to internal confidentiality concerns, or maybe due to government regulations, things like that. But on top of that, costs associated with data gravity concerns and latency issues might contribute to a desire to run some of the workloads on-prem. But then having that ability to federate some of your data so that applications and services can search and read from various data sources, regardless of where they physically reside, that's an important new concept, I think, that we're tackling now. And still, you mentioned edge. Typically, data was batch transferred to a central data center for processing from an edge location. Now, in order to accelerate business insights and data processing, data can be stored closer to that inception point today. And by reducing the amount of data that needs to be transferred back and forth between the remote site and a data center, you can decrease those costs, like your uplink costs and things like that, and reduce the latency and reaction time on a lot of the issues that you have coming up in that site. And then, critical data, as you go through all of that, you'll have a set of critical data that can all be mirrored or spread or tiered across edge, core data center, and cloud deployments for business continuity and for further operational processing, I think.
Okay, great. So moving on, I mean, how do you scale and still ensure performance? What are the key considerations there for Kubernetes?
Yeah. So, typically at Red Hat anyway, when we do a lot of the workload characterization tests, there are typically three areas that we try to benchmark across: resiliency, scalability, and performance. And especially when we're looking at high latency workloads like databases, we look at what can we do to optimize that performance. And for large scale projects, typically for things like data lakes or repositories used for analytics or AI ML workloads, in those cases we concentrate on how to maintain performance at scale. So we look at how we can augment data discovery using enhanced metadata in object stores, while pulling applicable data into high-speed parallel file systems for high-performance computing workloads, machine learning, scratch space, things like that. Now, I think there are a lot of industry trends, such as higher network bandwidth, better chipset throughput. There's a lot of accelerators, GPUs, certainly programmable cards, but even specialized processor accelerators for specific use cases like deep learning are all coming to the forefront these days. And all of these things, I think, contribute to better performance across distributed architectures, and it opens the doors for more interesting workloads to be delivered with acceptable performance across Kubernetes. But then, when we've done other things like tiering storage pools and native protocol support using APIs, and then architecting the underlying hardware for the workload in question, that's where we can start to optimize things even further. For example, in one case, we attribute high-speed NVMe drives to accelerate the metadata while using more cost-effective drives for your data tier, and that can help deliver that deterministic performance at scale that I mentioned before.
Perfect. Okay, so we just kind of, we promised this would be 15 minutes in the cloud, and we have a couple minutes left, and you've talked a lot about the trends that are coming, but are there any other business drivers or any other things that you think the future holds that you want to kind of wrap up with?
Yeah, I mean, I think immediately the major business drivers that we're seeing right now revolve around greater adoption of some of these workloads that we've been talking about. You know, databases, data cache, analytics, uh, AI inference, as well as machine learning, search and logging, all of these types of things. The challenges for these types of workloads, like business continuity and security performance, these are the major areas that we're solving for today. But moreover, as we look at the future, as we look at what's emerging in Kubernetes, I think it's really things like using the platform as the foundation for distributed event-driven architectures, right? And so there are some components like Knative that spawns applications based on event triggers, and GitOps and Tecton for pipelines. These are all incorporated into a Kubernetes platform, and that enables these new emerging workload patterns. I think to me the other big trend that I see picking up a lot of interest right now is around edge, and how can we do more actual work, not just at the enterprise or provider edge, but even closer to the device edge, right? So, looking at the infrastructure footprint, it's constantly being tightened. So storage needs to keep pace with the smaller and smaller footprint. So things like a single node Kubernetes deployment can now use the logical volume orchestration for the storage at that level. But what about things like Microshift that's being developed to extend Kubernetes further into the edge? I think developing data strategies from edge cache and mirroring or tiering data. These are the new trends that I see coming up within the industry visionaries anyway, that they're paying particular attention to today.
Okay, great. Wow. Well, that was a lot of great information on Kubernetes in just 15 minutes. So we delivered what we promised. So appreciate your time and all that information. And for people who want more information, in the SNIA Educational Library, there is a lot of information on Kubernetes, other sessions that we've done on this topic. And you can also always visit SNIA.org for more information. Thank you, Michael. This was great. Really appreciate all your insights.
Thanks, Diane. Yeah, hope to see Alex on the next call.
Sounds great. Take care.
All right, take care.
Bye-bye.